Hello, and welcome to Summarize Science. Artificial intelligence is everywhere, especially in our telecommunication networks that make 5G and soon 6G possible. But training these powerful AIs requires enormous amounts of data and energy. This leads to a big question that researchers from Ericsson decided to ask: are all training samples important? Or, in other words, could we train AI more efficiently by being smarter about the data we use? The standard way to train an AI is to feed it a massive dataset, assuming every single piece of information is equally valuable for learning. However, telecom data is incredibly complex and dynamic, with rare but critical events that can get lost in the noise. The researchers hypothesized that a large portion of this data might be redundant, offering very little new information to the model. This suggests a huge opportunity for selective training, making the process faster and more resource efficient. So, how did they figure out which data was important? They developed a framework that essentially gives each piece of data an importance score during the training process. This score is based on how much influence that single piece of data has on the model's learning at each step. High-scoring data is considered critical, while low-scoring data is considered redundant and can potentially be ignored. To test their idea, they used 3 different real-world telecom datasets. One was public data on internet activity in the city of Milan, another was proprietary data from a major telecom vendor, and a third was for 5G beam selection. Now let's look at the incredible results. In these first graphs, the blue line is the real-world data they tried to predict. The green line shows the performance of a model trained on 100% of the data, and it's pretty good. But look at the red line. This model was trained on only the most important samples, and its performance is almost identical to the full model. These bottom graphs show it even more clearly. They demonstrate that you can achieve nearly the same accuracy using just 70 to 75% of the most important data. After that point, adding more data gives you almost no benefit. The benefits weren't just about using less data. This table shows that by using a smaller, more focused dataset, they significantly reduced the training time. And here's the most important part for our planet: this method also made the AI greener. They measured the carbon emissions of the training process and found that their selective approach reduced emissions by an average of over 30%. So let's quickly recap what this breakthrough means. First, a huge amount of the data we use to train telecom AI is redundant and doesn't contribute much to the final result. Second, by intelligently selecting the most impactful data, we can train AI models that are just as accurate, but in less time and with less computational cost. And third, this directly leads to a more sustainable, green AI approach, significantly cutting down the carbon footprint of developing new technology. As AI becomes more and more woven into our critical infrastructure, making it efficient and sustainable isn't just a bonus, it's a necessity. Thanks for watching Summarize Science.